If an equipment grounding conductor is installed within raceways, the raceways must be bonded on both ends according to NEC 250.118.10. When a metal conduit run changes to non-metallic flex, the grounding path through the conduit is interrupted. To ensure a continuous grounding path, the metal conduit must be bonded to the non-metallic flex at the transition point, and the conduit must be bonded to the equipment at both ends of the run. This bonding creates a continuous grounding path for fault currents and ensures the safe operation of the electrical system. Firstly, the bonding jumper at the transition point must be sized appropriately for the fault current level. Secondly, the bonding jumper must be listed for use with both metal and non-metallic raceways. Thirdly, if the metal conduit is grounded using a grounding electrode conductor, the grounding electrode conductor must be connected to the equipment grounding terminal at each end of the conduit run. The purpose of bonding is to create a low impedance path for fault current to return to the source. This low impedance path facilitates the operation of overcurrent protection devices, such as circuit breakers or fuses, in the event of a ground fault. Without proper bonding, a ground fault could result in a dangerous voltage on metal parts of equipment, posing a shock hazard. The National Electrical Code, or NEC, provides detailed requirements for bonding and grounding electrical systems. These requirements are designed to minimize the risk of electrical shock and fire. Article 250 of the NEC is dedicated to grounding and bonding. It outlines the specific rules and regulations that must be followed to ensure a safe and effective electrical system. When working with metal conduit, it is important to understand the different types of fittings and connectors that are available. Some fittings are designed to provide a direct bond between the conduit and the equipment, while others require the use of a bonding jumper. A bonding jumper is a conductor that is used to connect two or more metal parts together to create a continuous grounding path. The size of the bonding jumper is determined by the size of the circuit conductors. The NEC provides tables that specify the minimum size of bonding jumpers for different circuit sizes. When installing a bonding jumper, it is important to make sure that it is securely connected to both metal parts. The connection should be clean and free of corrosion. It is also important to make sure that the bonding jumper is protected from physical damage. In some cases, it may be necessary to install a grounding electrode conductor to supplement the equipment grounding conductor. A grounding electrode conductor is a conductor that connects the equipment grounding system to a grounding electrode, such as a ground rod or a metal water pipe. The grounding electrode conductor helps to stabilize the voltage on the equipment grounding system and provides an additional path for fault current to return to the source. The size of the grounding electrode conductor is determined by the size of the service entrance conductors. The NEC provides tables that specify the minimum size of grounding electrode conductors for different service sizes. When installing a grounding electrode conductor, it is important to make sure that it is connected to a grounding electrode that is properly installed. The grounding electrode should be buried in the ground below the frost line and should be located away from any underground utilities. When working with non-metallic flex, it is important to use fittings and connectors that are specifically designed for use with non-metallic raceways. These fittings and connectors are typically made of plastic or other non-conductive materials. It is also important to make sure that the non-metallic flex is properly supported and protected from physical damage. When transitioning from metal conduit to non-metallic flex, it is important to use a transition fitting that is listed for use with both types of raceways. The transition fitting should provide a secure connection between the metal conduit and the non-metallic flex and should maintain the integrity of the grounding system. In addition to the specific requirements for bonding and grounding, there are also general safety precautions that should be followed when working with electrical systems. Always energize the circuit before working on it. Use appropriate personal protective equipment, such as rubber gloves and safety glasses. Follow all applicable codes and regulations. If you are not familiar with electrical work, hire a qualified electrician to do the work for you. Proper bonding and grounding are essential for electrical safety. By following the requirements of the NEC and using appropriate installation practices, you can minimize the risk of electrical shock and fire. Remember to always consult the latest edition of the National Electrical Code for the most up-to-date requirements. Additionally, local codes and regulations may have more stringent requirements than the NEC. Therefore, it is important to check with your local authority having jurisdiction, or OJ, to ensure that you are complying with all applicable codes and regulations. Understanding the principles of grounding and bonding is crucial for anyone working with electrical systems. Grounding provides a path for fault current to flow back to the source, allowing overcurrent protection devices to trip and to energize the circuit. Bonding connects metal parts of the electrical system together to create a low impedance path for fault current. This helps to prevent voltage differences between metal parts, which can create a shock hazard. The NEC provides specific requirements for the size and type of conductors used for grounding and bonding. These requirements are based on the size of the circuit conductors and the type of equipment being served. It is important to use the correct size and type of conductors to ensure that the grounding and bonding system is effective. In addition to the requirements for conductors, the NEC also provides requirements for the installation of grounding and bonding equipment. This includes requirements for the type of connectors used, the method of installation, and the location of the equipment. It is important to follow these requirements to ensure that the grounding and bonding system is properly installed and maintained. Regular inspection and testing of grounding and bonding systems are essential to ensure that they are functioning properly. This includes visual inspection of conductors and connections, as well as electrical testing to verify the continuity and impedance of the grounding path. Any deficiencies that are identified during inspection or testing should be corrected immediately. Proper grounding and bonding are not only important for safety, but they are also essential for the reliable operation of electrical equipment. A properly grounded and bonded system helps to reduce electrical noise and interference, which can improve the performance of sensitive electronic equipment. In conclusion, bonding metal conduit, especially when transitioning to non-metallic flex, is a critical aspect of electrical safety. Understanding the NEC requirements and following proper installation practices will help to ensure a safe and reliable electrical system. Remember to consult with a qualified electrician if you have any questions or concerns about grounding and bonding. They can provide expert advice and ensure that your electrical system is installed in accordance with all applicable codes and regulations. In addition to the points already discussed, consider the following aspects of bonding and grounding. Firstly, the type of grounding electrode used can affect the performance of the grounding system. Common types of grounding electrodes include ground rods, metal water pipes, and concrete encased electrodes. The NEC specifies the requirements for each type of grounding electrode. Secondly, the location of the grounding electrode can also affect the performance of the grounding system. The grounding electrode should be located in an area where the soil is moist and conductive. It should also be located away from any underground utilities. Thirdly, the impedance of the grounding path is a critical factor in the performance of the grounding system. The impedance of the grounding path should be as low as possible to allow fault current to flow back to the source quickly and easily. The NEC specifies the maximum allowable impedance for grounding paths. Furthermore, surge protection devices, or SPDs, can be used to protect electrical equipment from voltage surges. SPD are typically installed at the service entrance and the branch circuit panels. They divert surge current to ground, preventing it from damaging sensitive electronic equipment. Also, equipotential bonding is a technique used to minimize voltage differences in areas where people may come into contact with metal parts. Equipotential bonding is commonly used in swimming pools, spas, and other wet locations. It involves bonding all metal parts together to create a common electrical potential. Proper labeling of grounding and bonding conductors is essential for safety and maintenance. Grounding and bonding conductors should be clearly labeled to identify their function. The labels should be durable and resistant to fading. Training and education are essential for anyone working with electrical systems. Electricians should receive thorough training on grounding and bonding techniques. They should also stay up to date on the latest changes to the NEC. Electrical safety audits can help to identify potential hazards in electrical systems. Audit should be conducted by qualified professionals who are familiar with the NEC and other applicable codes and regulations. Correction of any deficiencies found during an audit should be done in a timely manner. Documentation of grounding and bonding systems is important for maintenance and troubleshooting. Documentation should include drawings, specifications, and test results. This information can be used to identify potential problems and to ensure that the grounding and bonding system is properly maintained. Finally, remember that electrical safety is everyone's responsibility. By following safe work practices and understanding the principles of grounding and bonding, we can all help to prevent electrical accidents. It's also important to consider the impact of modifications or additions to an existing electrical system on the grounding and bonding. Any changes to the system should be carefully evaluated to ensure that the grounding and bonding are still adequate. It's possible that the existing grounding and bonding conductors may need to be upgraded to accommodate the increased load or changes to the wiring. When dealing with sensitive electronic equipment, such as computers or medical devices, it's crucial to provide a dedicated equipment grounding conductor. This helps to minimize electrical noise and interference, which can improve the performance of the equipment. The dedicated equipment grounding conductor should be run directly from the equipment to the grounding bus in the panel board. In industrial settings, it's common to use a separate grounding electrode system for sensitive electronic equipment. This helps to isolate the equipment from the electrical noise generated by other equipment in the facility. The separate grounding electrode system should be installed in accordance with the NEC. In healthcare facilities, there are specific requirements for grounding and bonding in patient care areas. These requirements are designed to minimize the risk of electrical shock to patients and staff. All metal parts in the patient care area must be bonded together to create a common electrical potential. Regular testing of the grounding and bonding system is required to ensure that it's functioning properly. It's also important to consider the effects of corrosion on grounding and bonding conductors. Corrosion can increase the impedance of the grounding path, which can reduce its effectiveness. Grounding and bonding conductors should be inspected regularly for signs of corrosion. If corrosion is found, the conductors should be cleaned or replaced. In some cases, it may be necessary to use corrosion-resistant materials for grounding and bonding conductors. When installing grounding and bonding conductors in underground locations, it's important to protect them from physical damage. The conductors should be buried at a sufficient depth and should be protected by a conduit or other protective covering. It's also important to avoid installing grounding and bonding conductors near underground utilities.